so we are going over the answers to pages 7 and 8 here in your packet. So these are the practice problems that went along with concept 1. So let's look at our chart here. So you were looking at the element, you want to find the number of protons, which remember, that is the atomic number. Right, so remember the number of protons is the atomic number. So lithium is element number 3. It's in group number 1. Remember, groups go this way on the periodic table, up and down. So since it's in group 1, it has 1 valence electron. Anything in group 1 will have an oxidation number of +1, right? Because it's going to lose that 1 valence electron to give it, to become stable, which means that the ion is Li with a superscript or like an exponent of +1, right? Make sure you're writing those oxidation numbers as a superscript here. So sodium is 11, also in group 1, 1 valence electron, oxidation +1, so it's Na +1. Beryllium, 4 protons, group 2, 2 valence electrons, +2, and it's beryllium +2. All right, so remember when we get into the larger groups, so group 13 has 3 valence electrons, so it's a +3. As we get into group 15, 5 valence electrons, so that's going to be a -3, right, because it's going to gain 3 electrons to fill its outer energy level, right? So oxygen's going to gain 2 electrons, and fluorine would gain 1 electron. So remember, cations are ones that have positive oxidation numbers. So let's highlight here. So cations would be lithium, sodium, beryllium, and aluminum. And anions would be phosphorus, oxygen, and fluorine. So what does aluminum need to become stable? So it needs to lose those 3 valence electrons, so then its outer energy level is now full. So in number 5, what does phosphorus need? So phosphorus has 5 valence electrons. So since it's got more than 4, it's going to be easier for it to pick up 3 electrons than it is to lose 5. Right? So it wants to do the least amount of work as possible. All right, and then in part 2 down here, we're looking at the chemical formulas. So again, there's one, if there's no number beside it, you assume that there's one atom. So there's one atom of sodium, one of chlorine. So 1 Na and 1 Cl. NaSO4, so 2 Na, 1 S, 4 O. Remember, these little subscript numbers are going to go with, or are telling you how many of atoms of each element are in that compound. So H2O has 2 hydrogen, 1 oxygen. So this one's a little bit tricky. So since this 3 is outside, it just means there's 3 of this particular compound here. So that means you're going to take this, so there's 3 nitrogen, and then you're going to do 4 times 3 to get 12 hydrogen here. And then there's 1 phosphorus and 4 oxygen. So it's kind of like in math class with the distributive property, right? You're going to multiply that 3 through to both of these. Okay, and then here we've got the electron dot diagrams. So you've got potassium, which has 1 valence electron in chlorine. So you're going to take the 1, give it to the chlorine to get KCl. Magnesium has 2. So iodine, I believe that's a typo there. So again, if you have 1 iodine, you can get rid of 1 of those electrons. But since there's still 1 left, you're going to have another iodine atom to get it over there. Calcium, so, and oxygen. So you have 1, 2, 3, 4, 5, 6 here. So we have 2 open spots, and we have 2 electrons from calcium. So we can simply put those both there. Sodium and oxygen. So oxygen needs to gain 2. And since sodium only has 1, you just want to use another sodium. So again, you want to add what is going to be the least amount of work here, right? So we don't want to add another oxygen. We just want to add another sodium because that's the easiest way to do that to fill up this oxygen one. Again, we always want to try and fill the one that has more electrons instead of add another one. So aluminum and chlorine. So aluminum has 3. Chlorine has 1 open spot, so we're going to use 3 chlorines to take those 3 electrons from aluminum. And barium and nitrogen. So barium has 3. Or I'm sorry, barium has 2, right? Nitrogen has 5. So we have to fill 3 nitrogen spots. So we have the barium, so we're going to use 2. This one's really hard to follow. So let's start here. So I'm going to take this one and this one. So from this barium and put it with my nitrogen. So I still need 1 more though. So I'm going to add another barium, which I'm going to do in blue, and put that one here. So now I'm full with this nitrogen, but I still have this electron left. So now is when I'm going to need to add another nitrogen. So we're going to add that nitrogen, put that electron here, but now we need 2 more for nitrogen. So that means we can add another atom of barium, and that will fill my nitrogen and give me all 5 of these atoms now are going to be stable. So it's Ba3N2. All right, we will do more of these when we're back together next week. I hope this helped clear up some of your all's questions. Please post in the discussion. Let me know how it went, and let me know if there's anything else you guys want me to cover, because I really want to make sure we have a good understanding of this.